So this video is a practice video, and it's going to give you practice in solving quadratic equations using the quadratic formula, which I've written out up here. First of all, though, we're going to generate some random quadratics, and here's the little guidance about how to do that, but I'm going to walk you through this step by step. So lots of fun, kind of a game. Making maths fun for yourself means you're going to do more practice, you're going to enjoy what you're doing, and you're going to get a little thrill out of getting the right solution. So that's the way to make sure you practice, develop your fluency, and get the right answers. Okay, so the very first thing that we do is add our constants. So I'm going to, as it says here, I'm going to roll some dice. I've got 4 dice, and they give me 2. I'll fill 2 in here. What have I got? 4, 1 and 6. So 4, 1 and 6. So I've got my skeletal framework here, and I'm now filling in these numbers to randomly generate our quadratics. So next thing, add the coefficients. So to add the coefficients, I need 8 dice. I'm just going to do 2 at a time, in fact. So I've got 2 and 3. So 2, 3. Next one, 5 and 4. And then I've got 3 and 2, 3 and 2. And what have I got lastly? 1 and 5. So I don't have to put my 1 here, because if I don't put anything, it's still 1. So 1 and 5. So I'll put my 5 in front of my x here. Now, flip some coins. So add the operators. I'm flipping some coins. Heads can be positive. So I've got head and tail. So that's going to be plus, minus. You don't have to use dice and coins. You can just fill in things that you just fancy filling in, you know. But it's kind of fun. So I'm going to stick to my coins here. Okay, I've got head, head. So that's plus, plus. And finally, let's give it a proper flip this time, see if I can. Okay. Tail, tail. Alright, so I've got minus, minus. So this is how we randomly generate some quadratics, just using dice and coins. So let's remove that piece of paper now. And what I've done is drawn in some boxes here. And that's because the method I'm going to use here is the one that I showed you in the video, which is starting with the discriminant here, which I've written out in green. So starting with that before actually completing the whole quadratic formula. Okay, and that just makes it easier to remember. It's a sensible first step because it also works out if there are no solutions. So let's just give that a go and see if that works out with these randomly generated quadratic equations. So the discriminant is b squared minus 4ac. b is 3, a is 2, b is 3, and c is minus 2. So b squared is 3 squared, which is 9. So then minus 4 times ac. So 4 times 2. If I put them in brackets, it means you're less likely to make a mistake because it's so easy to leave off that sign. So I've got minus 4 times 2 times minus 2. So if we work that out, we've got 9 minus 4 times 2 is 8 times minus 2 is minus 16. So minus 16 means plus 16. So taking care then to make sure we've got this sign correct, and 9 plus 16 gives me 25. Okay, now at this point we'll pause. If we've got a square number like 25, which is 5 squared, then when it comes to working out the rest, we know that that's going to square root nicely to give me a whole number. And if that's the case, if you've got a square number here, so I'm going to give that a tick to indicate we've got a square number, you don't have to use the quadratic formula. You might want to switch just to factorising. If it's a square number, it will factorise. So you might want to put 2 brackets down here, and solve by factorisation. However, we're going to stick with the quadratic formula, so let's move on to the next one. So you might want to pause the video at this stage and have a go yourself. If not, just watch how I work through the discriminant and then see if you can pause it for the next one. So b squared is minus 4 squared, well that's going to be 16, and minus 4ac, so minus 4 times a, which is 5, and minus 4 for c, so minus 4, and then if we work that out we end up with 16 minus times a minus, so minus 4 times minus 4 is minus 4 squared, so it's plus 16 times 5, so it's plus 80. So that gives me 96. Now here's an interesting example. With this one we don't have a square number, so it's not a square number, and that means we can't use factorisation, we would have to use the quadratic formula, so we'll go ahead and do that. But interesting to just note, is this a square number? And if it's not, 96 is nearly 100, but it's not quite a square, so we do need to use the quadratic formula. So moving on to the next one. So b squared is 2 squared, so that's 4. Let's start with 4, minus 4 times ac. So a is 3, and c is 1. And that works out as 4 minus 12, which gives us negative 8. Now, this is an example that, in fact, will mean there are no solutions, that we cannot use any method to solve for x, simply because if I was to draw this out, it wouldn't cross the x-axis, it wouldn't even touch it, so there are no real roots. And with a curve that have an equation that has no real roots, there can be no solutions. We can't find any value for x that we could substitute into this equation, so it cannot be solved. So that's fine, that will happen. Not everything can be solved, not everything crosses that x-axis, but what it means is we've finished with this one. So we immediately write no real roots, so no solutions. And that one's finished. Okay, let's hope that doesn't happen with this one. Let's have a look. You might want to pause the video, do it yourself, but if not, just watch me work through it and see if that makes sense. So we've got b squared minus 4ac. So b squared in this case is minus 5, so minus 5 squared is 25, so we start there. Minus 4 times a, which is 1, times c, which is minus 6, negative 6. Okay? What does that give us? 25. Well, minus times minus, that's 24 times 1, so it's plus 24. Giving us a square solution, 49. So I'll give that a tick. That one would factorise, and you might want to use that method. In fact, that would be a good extension activity to factorise problem, let's call these problem 1, and 2, and 3. So you might want to go ahead and, as an extension activity, and factorise problem 1 and problem 4. Okay, now let's use the quadratic formula to solve the 3 problems that we can solve. So if we write x equals minus b, well b is 3, so that's minus 3, plus or minus. Now, we simply have to go to our discriminant now and pick out the square root. So the square root of 25 is 5. So that bit's done. And then for the denominator, well, it's twice the a value. So it's 2 times 2, so the denominator is 4, so divided by 4. Okay, just tidy that up. Okay, so you can see once you've got the discriminant, the rest is really quite quick and automatic. You don't really have to memorize the formula, you sort of more have to know what to do. You start with minus b, so minus that middle coefficient there. You write down plus or minus, and then you've got the square root of the discriminant divided by 2 times the x squared coefficient. Okay, so once you've done it a few times, pretty automatic. So minus 3 minus 5 will give us minus 8, so that's one possible solution over 4. Or minus 3 plus 5, so minus 3 plus 5 will give us positive 2, so 2/4. And if we simplify those fractions, we get minus 2, or 1/2. Okay, so you might want to pause the video at this stage and try the next problem. Okay, so if we write down x equals, we have minus b, so minus b is minus 4, so that's plus 4, plus or minus, and then the square root of 96, so that doesn't square root easily, so we'll just write that as root 96. And underneath we have 2 times 5, so that's going to be 10. Now with the next stage here, we could turn this into a surd. That would be to take 16 out, because 16, so that would be 4 root 6. So if you were asked to leave it in surd form, you would take that out, simplify that as 4 root 6, and then you're done. Mostly though, for this kind of problem, we want to draw a graph, let's say, then we really do want the decimal. What I'm going to do here though, I think, is just estimate it rather than reach for my calculator. So if I think of my root 96 as very close to root 100, then I can rewrite this 4 plus or minus 10 divided by 10, which is going to give me, well, it's going to give me 14 divided by 10, so that would be 1.4, or 4 minus 10, which would be negative 6 divided by 10, or minus 0.6. So that's the trickiest one in this video. Let's finally move to problem 4. So problem 4, x equals minus b, so b is minus 5, so minus b is going to be positive 5, and then our plus or minus, and it's the square root of 49, well, square root of 49 is 7, divided by 2a, and a is just 1, so divided by 2. So 5 plus 7 is 12 divided by 2, or 5 minus 7 is negative 2 divided by 2, gives us the solutions. 12 divided by 2 is 6, or minus 1. And as a final check, what you should always do, especially if you've got time at the end of an exam, is you should take these answers that you've got and plug them back in. Plug them back in to your original solution, your original equation. So we're going to check this one first. So minus 2 squared is 4, 2 times 4 is 8. And then you've got minus 6 here, minus 2, so that's minus 8. So that checks. So we'll say this one's correct. Okay. So if I put here my workings there, that would be 8 minus 8. And so you're looking for 0 because it equals 0, and this one's got to equal 0 as well. Let's see, half squared is a quarter, so 2 quarters are a half, plus 1 1/2 minus 2 does equal 0. So I'm not going to bother with this one here, I'm just going to tick that, say that is correct. So both solutions must be correct. A little more tricky with this one. This one you'll need to do a calculator check. So we'll just write calc. But if you check those, those should both work out to be correct. And finally, we're going to plug in 6 and 6. So let's check this one. 6 and minus 1 rather. So 6 squared is 36, minus 5 times 6, so that's minus 30, minus another 6 brings us to 0. So it's 36 minus 36, so that one's correct. Let me just tidy that up. There we go. And for the second one, well, it's minus 1, so it's minus 1 squared is 1. Minus 5 times minus 1 is going to be positive 6. So we've got 1 times 1 plus 6 minus 6. Yeah, so that doesn't work out. That's interesting. What's gone wrong there? So it's minus 1. Let's just put our workings here. Minus 1 squared gives us 1. Minus 5 times minus 1 is minus 5, so that's minus 5. Oh, there we go. I must be tired, so that worked out. So 1 minus 5 is 6, and then we've got plus minus 6. Whoops. Minus 6. So 6 minus 6 equals 0. So it does work out. Thank goodness for that. So 6 minus 6. I'm just going to write here, and that one's correct, and that one's correct. So that's how to work through some ideas. Work with the quadratic equation, but the main purpose of this video is to give you your independence. So having seen me work through these things now, have a go yourself. See if you can randomly generate some quadratic equations and then solve using the quadratic formula. Okay.